Hello everybody, thank you for coming. Today we will speak about our experience as cloud providers with OpenStack joined with Open Compute. So let's see if it works. Okay, we switched to a pink presentation. It's not the original color, but I hope you'll enjoy it. So just a brief introduction. The slides come from the marketing and they forced me to have this long introduction on the company, so let's go quick. These are the figures. We were a very small company based in Milan, Italy. We were 70 people, 18 of them dedicated to cloud services, and then all of a sudden we have been acquired by this size company, so we have been put in a much bigger pond than before. So now we have these revenues, and we are 700 more people. The company is called Iridios and is owned 80% by F2I, which is funds to infrastructure, and it's basically owned by the Italian government plus some European Commission investment funds. And basically they invest in long-term infrastructure, which is airports, motorways, and ports, and data centers and pipes. But they were interested in us because they needed a software layer to abstract some of these infrastructures and to expose to the customers. So this is basically what we own in terms of optical fibers and data centers. Most of the Italian internet runs through the Caldera campus in Milan, where 95% or more of the traffic runs by. And we own 15 data centers there. Plus the Avalon campus is the most interconnected campus in Italy. So if you want to go to Italy with your transport network, you have to be there. So this is the Italian network and the infrastructures we have. The services we provide, we aggregate services, we resell them. We are not a system integrator, we are an infrastructure company that provides services on top of it. So we are basically a larger ISP. This is the map for the network. That's an heritage from my former company. We were able to build a presence all across the world in terms of POPs. 60 POPs ranging from the US to Hong Kong and Singapore. We have a very good relationship with international carriers, so we are pretty much known in the telco world, even though we were pretty small. These are the services we provide in terms of cloud. There are three services. One is the VMware based, the other one is OpenStack based, is the one that I worked on to directly, and the third one is a vertical based on SAP on top of VMware. Who am I? I studied totally different subjects and at some point very late in my life I discovered I was an engineer inside. Usually it happens the opposite, so I was alone on the highway. Everyone coming from engineering to music, I was doing the opposite. I was going backwards basically. And I worked on Linux in the beginning. I was passionate about Linux and Linux manuals, paper manuals, because there were paper manuals at the time. And I contributed to develop the first Italian OpenStack public cloud, one of the first in Europe. In 2011, we started with the Cactus release. It was unusable, I can admit it, and it was unusable until Havana or Icehouse. So we spent a lot of time in fixing things. What I learned is that when you join open communities, you get information much faster, much better, and you meet a lot of fun people. So I become fond of open communities, collaborative communities, and that's why I'm here, for the people and for the food, basically. So I'm still passionate about open source and about free knowledge. I think internet is one of the most democratic things that happened to us, and that's why I joined the Open Compute project. from the very beginning. So, what is our public cloud? It's entirely open source. Entirely means entirely. We don't pay any license. We run KVM as an hypervisor. We run Ceph for block storage. We run Swift for object storage. We use Open vSwitch for SDN. We use HA proxy, Nginx, Apache, MySQL, Redis, everything open source to run our cloud, so from the controllers to the workers. We work with several providers, suppliers that support the open source. And that's it. So basically it's a public cloud with open APIs, open standard APIs. We didn't fork anything. We used the standard open. Who is familiar with Openstack here? Oh, pretty much. Okay, well, very good. And so you know that you can buy a packaged OpenStack, or you can use the community one. We have chosen the community one, and we decided to support the community, not to go with one vendor. What we have done is that basically building our cloud, we learned how to do the cloud and to use the cloud, because it's like a fractal. I mean, a cloud is an application. A public cloud is an application. It's basically software on top of hardware. So when you learn all the complexities of a public cloud, basically you are getting ready to provide services to your customers which have to use your cloud. So it's something self-feeding. It's a feedback and iteration process. How OpenStack is built is basically, this is a very, very high level for the ones that don't know OpenStack. OpenStack provides an API, a set of APIs to interact with infrastructure, and basically provides compute services, networking services. By networking, we mean DHCP, DNS, firewalling, security policies, and load balancing as a service, etc. Sorry, I forgot to just shut down my telephone. Storage means local storage, ephemeral storage inside the VM, and block storage, which is the SAN, basically, and object storage. Everything is on standard hardware, and we'll see how we have built it. This is the service architecture. We have built 3 regions, one in Milan, one in Frankfurt, one in Amsterdam. That's where our network POPs were. We basically bought an IRU for 10 years for a 10 gigabit Ethernet. So every region is a failure domain, separated, share nothing from failure domain. So we can lose one region, nothing happens elsewhere. I know bigger providers that when lose something in Virginia, they have a cascading effect, and I don't recall the name. Basically, the only thing that we share is a Galera cluster across the regions, by which we share the users. A Couchbase, not Couchbase, it's Memcache now. Memcache replicated database for tokens for authentication, so when you switch region, you don't have to re-authenticate. And the object storage, Swift, is designed to scale pretty well, and it has 3x replica that works by async writing the data across all the data centers. So whenever you use object storage in Milan, in seconds you have the replica of the data in Frankfurt and in Amsterdam, and it happens everywhere. It comes very handy when you use Swift to store the snapshots of your images, your virtual machines, into the object storage, because it's Veeam for free and instantly usable. You know Veeam? Everyone knows Veeam. It's the tool you use in VMware to make disaster recovery. So these are the services we use. I would add CDN. I'm sorry, I forgot this slide in Italian. CDN is a partnership with a European partner that has POPs all over the world. And DNS is something we developed inside. We designed, we wanted something that was like Route 53, so API driven and with geo functionalities. But we liked more the design of DNS with Anycast, so we built our own and we designed a Anycast-based, API-driven, geo-balanced DNS. So basically, you can design dynamic records to react to events by API. It's hard to maintain a DNS when you write it. Okay, so don't do it. Buy it as a service. There are plenty now. So mistakes. So this is all the services we do. We are working on a bare metal as a service. Unfortunately, the OpenStack community is very good for some things. The core services in OpenStack are rock solid and battle tested. Some of the other side projects, which are not actually side, like database as a service and bare metal, are still under development and they are not production ready, so there are some things to be fixed. So if you are building an OpenStack cloud, if there is anyone still trying to come over and ask for details if you want after the presentation. What we bet a lot is on managed services, because if you are not Amazon, Google, or Azure, you don't have the massive scale. There's a huge niche where you want to be in terms of trusted advisory when your customers have to go to the cloud, and then they need to find someone to bring them by hand on the cloud. Okay. This is the interface we developed, and okay, we start here with the point I want to make here. So basically, if you do the cloud as a replacement for VMware, you are not doing the cloud. Okay, so VMware is a virtualization. I know that can sound pretty obvious to many of you, but trust me, it's not. Okay. Some people call VMware-based infrastructure cloud. No, it's not. Okay, so cloud is all about APIs. Cloud is all about machines talking to machines, and with no human intermediation. There's no human clicking on an interface, etc. There's a software taking metrics from anything and sending commands to the infrastructure, and you want them to be executed in seconds. Okay, this is something you don't do with humans in the middle. So if you want to do this, you have to go through this process. Anyone familiar with this design? No one? This is the DevOps symbol. Okay, yeah, good. And this is the DevOps cycle. When you decide to do DevOps, it means you are doing ops, operations, using the development approach, which means you have to go through the code, the plan, the code, and then build, test automatically, then release in production, you deploy, then you test what happens, you operate it, and you get the feedbacks and you use the feedback, and then the yellow turns blue again to plan what you are going to do. This is very important. I was talking to the Mellanox guys during lunch about the importance of metrics. You have to meter everything. Everything you consider a problem is not a problem if you don't have numbers to say it. Okay, so you have a threshold and then you have a number, and if you are below or above the threshold, then you don't have or you have the problem. Okay. This also is a statement that they may sound obvious to engineers, but it's not common to see people. A lot of times feelings come in the middle, and you mistake real problems with fears. So what we have developed in building our customers' infrastructures on top of our cloud started to be repetitive. We noticed that the design we had was always the same. We have a balancer or a couple of balancers. We have a pool of front ends with reverse proxies, caching servers, and then we had web servers with the applications. We had a Git for storing the code to be deployed. We had Jenkins to automate deploying in the most advanced versions of the customers. We had databases like MySQL or Postgres or whatever else, MongoDB sometimes. And then started to pop up some requests for Kubernetes. We needed to have a RabbitMQ message queue to bring messages all across the distributed application. We are speaking here about cloud-native applications. So we decided to just, instead of reinventing the wheel every time, just to bake everything into Ansible scripts. And the Ansible script, we decided to orchestrate them because at some point the Ansible script was always the same. We just needed to change some parameters. So we built a pipeline with Git for storing and versioning the code, and then Gary to authenticate, and Jenkins just to collect the code, pack it, and deliver. And basically we built this tool that's called Automium, which is automation, and Automium, which is a symbol of Europe. We are very European friendly. And basically we provided it to customers. And Automium now can speak to OpenStack APIs, can talk to vSphere APIs, vCloud APIs, because at some point you understand that you can abstract the infrastructure really from the underlying hypervisor, the underlying cloud provider. In the future, in the next few months, we will release AWS and GCP, Google Cloud Platform, because it's very simple. Once you have abstracted it, it's VMs and block storage, and it's very easy to decline it. As long as you don't get caught in the lock-in and you don't use native services, that's what the providers want you to do, to get locked into. So you use Lambda, you use RDS, you use Aurora, you use all the fancy Kubernetes features, you are locked in for your life. I told you, write it down, I told you. So this is the design. So basically you have the hardware, then you have the separation, the isolation at the network level, or you agree, right? You agree, okay. So I'm on good track. So you have the tenant isolation, so you have the VXLAN, you have isolation at the networking level and the physical level. You have your networks, you have your compute node, your storage nodes. Then on top of that, you have your VMs. And then if you want to spin up Kubernetes clusters, then you build your namespace, and then you put your application. This is the stack we have to manage every day, okay? So it's a vertigo, basically. But what you can do is, if you abstract whatever you do on top of that, you can switch providers and you can do whatever you want, as long as you don't get caught in the lock-in. Okay. So Automium basically helps us doing this. Why did I spend so much in explaining what we do? Because, oh yeah, I forgot, we won a tender with the European Union in 2015, 34 million awarded not only to us, to 5 providers, to 5 cloud providers, which are Accenture with Microsoft, IBM SoftLayer, British Telecom, Atos, and us, for providing infrastructure as a service to the European institution. It was one of the happiest days of my life, actually, that day. Then after, yeah. Why OCP? Because of this. If you abstract properly and you use the layer, the isolation, and the segregation of duties inside the cloud, you can switch providers, you can switch things inside. If you go vertical, maybe you get a better performance, but you are stuck in that place until you just rebuild it. So if you automate the deployment of your infrastructure as infrastructure as code, you go infrastructure as code, you do DevOps properly, then you can abstract the underlying infrastructure. Given it is physical hardware, it can virtual machines, your VMware installation at home, or a public cloud provider. So if you plan to do any of these, remember that if you abstract and you automate the deployment of your infrastructure, you are getting a lot of benefits. I don't have time to explain how many, but it's incremental, it's versioned, it's authorized, it's an asset for the company. Everyone leaving the company is not bringing away the value of the company. The value is remaining in the company. So whatever, it brings the value on the upper layer. So it's a responsibility shift from the underlying vendor. Now is the storage. I have signed a contract by which they do everything if it happens. So I have an infrastructure like this. Here is the storage, and everything is just on the feet of everything is in the storage. And then I have the servers, and I have a contract by which the server provider has to intervene for maintenance, emergencies, etc. And then I have the hypervisor, and then I have the application. The paradigm of the cloud is the opposite. I distribute as much, n+1 everywhere, and the top is the application. The application leads, and much of the high availability of the application itself is in the application, not in the hardware. So the hardware has become pure commodity. So these are some points I wanted to outline. The traditional vendors are having a hard time to understand the cloud native model. It's impossible to deal with traditional vendors, I won't name them, and talk with them about cloud native model. They just decided to jump it and go to AI and IoT, the next buzzword. They didn't understand the cloud native model. Okay, why? Because the cloud native model at its own core means the hardware is no longer important. When we had to decide which switches to choose for our top of rack and our leaf spine architecture, we decided to go with a vendor that provided the best silicon. Why? Because the forwarding plane was not more interesting in the hardware as much as it was in the software, and the software was run by Open vSwitch and Neutron. So we just needed the best silicon possible, and that's why we went with the friends at Mellanox. They supported us greatly. The cloud native teams don't want to be stuck into black boxes. Every day you see new technologies coming up, Elasticsearch, InfluxDB, Kubernetes, apt.io, Heptio, etc., etc. Every day they want to plug in different components and change them, so they want to be free. You cannot do that if you are in a black box stuck by a vendor. Yes, you have support, but most of the time the local support, unless you are close to the place where they design it, which means in the Silicon Valley mostly, you're not getting the same level of support. Okay. So what we had to do was to understand exactly what was the purpose of our software, especially Neutron. Neutron has processes that want to have a single core very fast, whereas maybe Ceph can use multiple cores and split the load across different cores. So you have to know exactly what your software does in order to go on specific purpose hardware. So you don't need general purpose hardware anymore. So you're gonna save money and headaches on buying something stuffed into a server that you will never use. So how did we do that? We have been working with Jean-Marie Verdun. He's there, okay. This guy is a genius, especially about OCP, but about many things. And we started working about the Rugged Pod, which was a box that was supposed to run on top of the floor under snow, rain, and sun. Because if you move all the intelligence of your architecture into the software, then you can put whatever hardware wherever you want. All the rebalancing in cloud native application is very simple. Then they started to be involved in the OCP. He just brought me in. I started to test something, and we ended up buying some OCP Facebook decommissioned hardware. So what we did is OpenStack supports what it's called host aggregates and flavors. Basically, you can map a flavor of your instances to a host aggregate, which means that this flavor must be run on these physical nodes. And what we did was to map what we call the O1, which stand the O1 class instances, which is the OCP first class, to these Facebook nodes to provide the spot instances, which are not exactly the spot instances as Amazon. Amazon provides spot instances which are the spare capacity they have. They provide it to you at half the price, not really half, but almost. And whenever they need to claim it back, they just kick you out without warning, so you know that you can run only dynamic workloads on that. We built specifically designed hardware infrastructure to run our spot instances, and we started to sell it 1/3 less than Amazon. Okay, how we did it? We didn't provide any redundancy to the nodes. We bought this decommissioned Facebook refurbished hardware with this kind of configuration. We are pretty happy with that. We ran the Mellanox Connect X3. There are 3 because they were used, so it was the generation before. And how did we use it? Okay, this was the first use case. These guys led us to build it because until then it was just a POC. But with these guys, the problem they had was they had 2 services. One is streaming football matches, real-time TV, and the other one was and the other one was video on demand. On the video on demand, every video on demand player, also Netflix, do this. They receive the original master of the video. They just provide it to a feeding like pipeline, and then they chunk it in pieces. Whenever you go fast forward or fast backwards, you basically are just jumping from one chunk to the other. And what happens is that every file is split into chunks, and every chunk is encoded to 7 different resolutions, okay, from the big 55 inches screen, 60 inches screen, OLED, Ultra K, Ultra 4K, etc., to the very small old iPhone 4, okay. And all these chunks are then fed to content delivery network by which the users collect it. So basically they needed a very a cheaper solution than the Google one, the GCP one, to collect these chunks and to encode. So they use it for small bursts. The time they asked us to use to the entire encoding of the chunk was 8 minutes. In 8 minutes, we had to launch the machine, download the code from their internal Git, execute the code, download the chunk, encode it, spit it out, and stop the machine. Okay, do it with the system administrator. Okay, and they spin up to 400, 500 virtual machines each every time. Okay, so they just do a burst of a parallel. They asked for a time, for a boot time for virtual machines below 2 seconds. Okay, 2 seconds. So it's quite challenging. We did it. Okay, they are running our infrastructure. The other one is a very well-known Italian company that runs ads in TV. They basically broker contracts, insurances, mortgages, etc. You have the same thing in your country. And basically they have a lot of evaluation they have to do in comparison between different contracts, and they run a lot of ads, so they decided to move to Kubernetes. So they have a battery of Kubernetes nodes in front that elaborate this stateless application, and they have these huge databases on virtual machine on the back. So Kubernetes also is a good use case for this. The same, this is a pretty known newspaper online. Same thing, they have the problem that when something happens locally, it's now the time for local newspapers. We have, after gigantic news feeds, now we are going back to local news, and every time something happens locally, they have this kind of burst of accesses, because they know that these guys know the things before national newspapers. So they wanted to have Kubernetes clusters to scale their application up to 100,000 connections all at once, so very quickly. So they wanted Kubernetes. So this is how to summarize how can you leverage OCP in production. So highly automated workloads, because if you choose something that may fail, not because OCP design may fail, but in our design, it was designed with no redundancy, our target was cost. So we had to take away everything we could. You have to use highly automated workloads, because you have to rebalance quickly. Burst workloads that don't care if you lose a node or two. You just have the remote script to relaunch the batch on another node, as long as it senses it. And stateless applications, I wouldn't put on this kind of configuration any database or a persistent application. And better if it's highly distributed. So if you want to do stateful, you want to put your files in it, at least ensure a 3x replica of your data. By the way, we tested and used OCP also for running Ceph and running Swift. Okay, so you can do both easily, as long as they have a software-defined 3x replica. So that's it. I don't know if you have any questions. If we have time, no, I'm very late. Sorry. And if you want to ask me anything, I'll be around here afterwards. Thank you. Thank you very much.